AQA A-level chemists, if you don't understand how this reaction mechanism works, you won't understand how any of them work. What we're talking about here is nucleophilic substitution. This is where a nucleophile reacts with a haloalkane. A nucleophile is anything that can donate a lone pair of electrons, for example the hydroxide ion, and a haloalkane, if we break down the word, we know is a molecule that has a halogen attached to an alkyl group. So in this case, bromoethane. The trick that I always like to use when I'm doing mechanisms is I always like to ask myself what here is negative and what here is positive. I know in this case the hydroxide ion has a 1- charge, so it's negative, and I know that bromine is more electronegative than carbon. What that means is within this CBr covalent bond, bromine is able to pull the electrons towards itself. It's almost like tug of war. Bromine is stronger than carbon, so it's able to pull the electrons towards itself, making bromine slightly negative, or we can say delta negative, and carbon delta positive. Once I know what here is negative and what here is positive, that's going to tell me exactly how my mechanism is going to work. The lone pair on the hydroxide is attracted to and attacks the carbon, right? Because negative is attracted to positive, and at this moment in time, carbon has 1, 2, 3, 4, 5 bonds. 5 bonds. It only wants 4. Carbon usually only makes 4 bonds. So what it does is it kicks one of these atoms out. And the one that is easiest to kick out is the bromine. So bromine gets kicked out. In terms of products, the OH- which attacks the carbon swaps places with the bromine, in other words substitutes it, and this forms an alcohol, in this case ethanol. The bromine that gets kicked out just forms a bromide ion, and these are your two products. If you found this useful, follow for more AQA A-level chemistry tricks just like this.